Hello, welcome everyone. While more people join in to this session, we have with us Mark here, and as you can see on my screen, where we were playing the piano arpeggio, which is generated by a text prompt. So we'll go into like a lot of detail about the research that has taken place behind it and how Mark has been using the tools that stability.ai has released to be able to generate such kind of music. So yeah, sit back and enjoy. And over to Mark. I'll stop my screen share now.
Okay. Yes. Yes. Thank you, Sid, and thank you, my fellow Colonel friends, for having me. Um, can I share my screen here?
Able to? Yeah.
Can you guys see it? Okay.
Oh, nice.
Cool.
Yeah.
Cool. Cool. Um, let's see. Let me pull up the chat too, so that I could see if people are dropping stuff in the chat. Midnight party from Singapore. Okay. So where's everyone at? I'm just very curious. I'm from LA. Where's everyone at?
Texas.
Singapore.
Texas, SG,
Update is
Charleston,
also from it.
South
Yeah.
Carolina.
South Carolina, New Mexico. Amazing. Okay, cool. Central Time, Eastern Time, Singapore time. Um, amazing. Sick. Um, yeah, again, I'm just very excited to be here and to share it with my fellow Kernel folks. And I know that just by being part of the community, I know that a lot of us here. I think to be a Kernel fellow is to be curious, right? And so for me, I've been curious about AI for a minute now, and been playing around with systems, different models and different modalities. But one thing that I've noticed is that a lot of these architectures are kind of like shared by models. And initially, as I came to it, I was sharing with Vivek earlier that when I started, it felt like a black box to me. I was like, I can't understand what's going on with this thing. Um, but then later on, as I started learning about it, both technically and started sort of like reading more research papers, I see a certain pattern. It's like, some of the patterns are actually shared. Some of them are pulled from, software development understanding. Some are pulled from mathematical understanding. Some are sort of like uh, psychological too. Or neurobiology. So it's just very fascinating to me. Um, Before we dive in, I wanted to start with this quote that I recently encountered from the book Surfing Human Creativity with AI, written by Nao Takui, who is the founder of Newtone, a music AI company as well. If you guys are musicians, check out Newtone. They do wonderful work. Um, and this is the quote. Um, I believe that the attempt to make a creative machine will help us greatly in finding out how we ourselves create. And so to me, that really resonated because, with the act of actually building these intelligent systems, we get a peek or a chance to understand how human intelligence, creativity works. Not exactly, but it gives us a sense of understanding, right? And so that's really very inspiring to me and something that I hold dear to me, as I sort of like journey on and sort of like learn more about these systems. And so I invite you also to sort of like keep that also in mind. Just really briefly, I'm pretty sure that me being part of the kernel directory, some people probably know me already, but just really briefly, I'm Mark. I'm based in LA, and I've been a professional musician for more than a decade now. And I'm also an aspiring machine learning engineer. I am part of Songcamp, or part of the founding team of Songcamp, a Web3 laboratory playing at the edges of music in Web3. And yeah, most importantly, I'm here to collaborate and learn from you all. as well. Here are my socials if you want to follow or connect. So here's a paper that we're talking about today. What this really means is the folks at Stability AI has built a model that can generate longer form music. And this is actually quite special because the preceding models that came out could not generate longer form music. It would usually max out at 30 seconds to a minute. So when this idea came out, it was quite novel. And here's the if you're technically inclined, this is the link to the research paper. So just a brief history. I guess in terms of like stable audio, it was first released last year, complete with its own interface, stableaudio.com. And then just this year, they released version 2. And the thing that I really appreciate about Stability, as well as a lot of us here coming from crypto, is the open sourceness of things, right? Like they can decide not to share this with us, but they've written a research paper, essentially the recipes of how they built this thing. And it's just so fascinating, and I think that's something that I appreciate, and especially in open source AI, that the code is there, the data sets are transparent, and you could actually play around with it. You could download it to your computer, and you can experiment. So this specific paper that we're talking about here is released last month, so it's quite fresh. Although we've seen much more higher quality models such as Suno or Udio. I think that it's important to talk about this because a lot of these, in the same, I guess a lot of us here come from crypto, so I'm gonna be using a lot of like crypto analogies, right? Um, a lot of like how Bitcoin is made, uh, kind of like carries through in understanding Ethereum. You know what I'm saying? So I think the same sort of like pattern also sort of like exists in AI. People actually build on top of each other, which I think is like what really technology and creativity is. We actually built on top of each other. And so to me, even though this is kind of a little late, I think it's still important to talk about this, to understand the future iterations of these music models. Um, let's do a quick demo. Let's make this interactive. I know that Vivek was already generating some stuff in the background, but I would like to invite you guys to let's build a prompt right now. I have stable audio pulled up. Um, let's build a prompt. Let's start with a
Avdesh,
genre. Go ahead,
yeah,
Vivek.
I'm curious, Avdesh, which instruments would you like to add to this prompt?
I'm thinking of something like lo-fi R&B with a harmonium.
The
B
yes.
Yeah, the BPM can be like around maybe like 60 to 80, not sure about that. And
Okay.
harmonium plus, let's say, harmonica, like the mouth organ. Both of them are like wind instruments, so I'm not sure how it's going to work, but let's see.
You're
Okay.
you're you're pushing the AI.
Yeah, I just want to test this model.
Mark,
Okay. Yeah. Okay. I
I've
like
been
it.
practicing. I'll put harmonium in the chat. It's a beautiful, like organ-like instrument.
Harmonium. Okay.
But like, yeah, you got it.
Oh, sitar also works. Yeah, sitar also works.
Okay, let's confuse the model for sure. So we have harmonium, sitar, strings in the lo-fi R&B style at 80 BPM.
Wait,
Yeah.
maybe instead of strings, I feel like drums. We need drums, right?
I think it's gonna add drums.
It'll do it. It'll do
It
it.
will
Okay.
do it. Yeah, yeah, because it's.
I think. Oh, sorry.
Go ahead. Go ahead.
Sorry to cut you off, but I think sitar is like a form of string instrument. So maybe it will like add to like string instruments. I'm not sure.
Yeah. You see, that's interesting to me. I think what's happening right now, even though we're building a prompt, we're also already sort of like almost inferring, and almost predicting what the model will understand. Um, and that's pretty cool. But I think my tendency is to like I want to confuse the model as much as possible. So I still dump everything, all the words on there, and try to see if we could get something really weird. But anything to add?
In the chat, Sid had anything from percussion family drums. Cajon? What is that?
Cajone?
Is that what it is? I don't know.
Yeah.
Yeah, yeah.
It's like a
Cajon.
yeah, a percussive instrument, like a box, right? Cajone?
Yeah, like a box. Yeah.
Yeah. Let's
Okay.
okay. Let's add a cajone there. Okay. Harmonium, sitar, strings, cajone in a lo-fi R&B style at 80 BPM. Okay, let's generate. So so if you see the interface right here, right? Like if you're like starting from scratch, they also have like a prompt library to sort of just like ease in. If you have want to generate ideas, we're going to use the latest model, and we are going to let's just do 1 minute, so that it wouldn't take that much time. The interesting thing also is that this is a text to audio model, right? You could also do audio to audio. So for example, if you're actually beatboxing and you want that to actually guide the model generation, you can also add it here. Okay, so let's generate. Aliyah, what is this? I'd love to add Buzuki / lute. Let's add a lute. Let's add a lute. Okay,
You got
here we
this
go.
bazooka. Mark, while it's generating, you might want to like re-share your screen, but like check the box that says share sound, unless you've already done that.
Oh, okay. Good flag. Let's see. Audio settings. Uh, original sound.
If it isn't coming up, I know for sure. Like if you stop your screen share and then re-share, it's like a little checkbox that comes up on
Okay.
the first screen.
I believe I set that
Okay.
previously.
Cool.
But if this doesn't work, then I'll do it.
Cool.
Okay, it's generating right now. I'm using the free version, so I don't know if I'm deprioritized in the queue, but we'll see. Okay, now it's converting. Has anyone used other AI models? Oh, we have it here. Okay, you guys ready?
Ready.
Okay, let's hear it.
Okay, I think we can't hear it, Mark.
Okay, copy that, copy that. Okay, let me reshare my screen. You're right, Vivek. Yeah, there is actually a click box. Let me unshare. How do I unshare?
I can help with
Oh,
that.
stop
Maybe.
share. I got it,
Yeah.
got it. Got it.
Okay.
And then reshare. And then share sound.
Yep.
Share.
That'll be
Okay.
it.
Here we go. Okay. I'm curious to hear your guys' observations and comments on the output. What do you all think? Is it good? Is it bad? Is it confusing? Is it what you actually had in mind?
It was better than I expected.
Okay, okay.
Yeah,
And
same,
it was
same.
it was in the middle in terms of like that is almost something I would turn on turn on to listen to. I mean, with some like adjustments, I
Mm,
think.
Yeah,
But yeah, like
yeah.
you said, culturally confusing.
It is, yes. Any other thoughts?
It felt like there was like one segment that was like almost out of tune, or like something that I feel like it feels to me like a human would not consider it, which to kind
Mm,
of funny because it's not that it was wrong, it just felt like very different sounding. I mean, I could probably point it out, but it's like there's
yeah.
like one part that was like almost out of tune to me.
Yeah, yeah, yeah. No, totally. It's almost like there are some parts of it that are, I guess to put it in stats terms, outside of the distribution, right? This is like
Mm.
human understanding, it has the curve, and some parts of it are outside of our understanding, and so quite confusing sometimes, but interesting and creative. Advesh?
Yeah, I think what Vivek was mentioning was, I think, the first like 20, 30 seconds, or after that, like after those 20, 30 seconds. I think that was where it got out of the rhythm. But apart from that, it was all fine. Like somewhere in the middle, it was very good. Like, the drop
Mm,
and the stuff. That was
yeah.
actually very cool.
Yeah, it's interesting that you pointed that out. I think it's one of the, I guess the researchers were sort of talking about how through their training, their intention was to really teach a model the structure of a song. So if you guys notice, it started with an intro, right? With the lute, ding 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 ding, without the drums, right? And then it understood, after a few bars, let's now put the drop here, and then the drums started actually happening, which is quite fascinating. That wasn't possible before. When you prompted a model, it would just generate whatever is on the prompt and go endlessly, into all these confusing routes, which is good for experimental music, but if you're wanting something much more coherent, it's not useful. So yeah, this is fun. Thank you for indulging me. Definitely will download this track here. It's now saved in my thing, and maybe I'll also share it with you guys. um,
Share the link
Avdesh, you,
with
you have your
yeah.
hand up.
Yeah, first this model, right? For the stability.ai model, can we convert the AI generated clip into MIDI format, or like,
That is a good question. Let's check.
so that we can, like, adjust the rhythm and everything?
Oh, no. It's
No, right?
audio only.
So
Yeah.
MP3. Okay.
Yeah, wave file or MP3. Yes.
Okay.
Yeah. Some models can do that though. If you're interested in doing something like that, I would recommend cassette.ai. Um, it's also, I don't know exactly what model they're using, but when you output something, you can actually generate the MIDI file for it that you could use later on for your own productions. Um, um, so just a quick word on like the structure of this discussion. I'm gonna talk about what I think we touched already on what were the previous approaches in building a music model, and then compare and contrast that with how the models of today are being made. Um, we're going to talk briefly about the model architecture. We don't need to go too much into the technical details there. We're going to talk about the training, how they train the model, what data sets they've used. And this is important because there's like an issue with a lot of like models. or a lot of like these big research labs and companies not being transparent with their data set. Thankfully, Stability is very transparent with their data sets. We're going to talk about how they measured the performance of the models, and then a recap, and then we'll have some space for discussions. But please interrupt me if you have a burning question. No worries. We have a small group. I want this to be as interactive as possible. So let's start with the approach. So when building these types of models, right? We have earlier models like I think OpenAI made their own, which is Jukebox, I believe it was called, or was it Google? But with this earlier models, the earlier approach was when building a data set, they would have songs, like say for example, like a 5-minute song, a Beethoven track, 5 minutes. And what they would do is cut up 10 to 30-second chunks from a long track. And they do that across many tracks. And that becomes their data set, right? But the problem with this approach is that the model does not learn the song structure. It only learns little bits and pieces and just connects or interpolates them, and did not really give a lot of like, it doesn't sound like a song. Now in the new method, they've trained the model on longer tracks, 3 minutes to 4 minutes. And so the model has learned song structures. The output has become much more coherent, and much more pleasant to actually like follow and listen to. I'm pretty sure you guys are aware too that with a lot of with training large language models like ChatGPT, people use tokens, and I think this is a different kind of token. Although I guess in spirit the same. A token is a representation of something, right? The same also for AI. It's a representation of a data point, or a theme or an idea. Earlier methods use semantic and acoustic tokens. Think of this as just really complex numbers that represents a theme of music or the actual sound of the music. But the thing with using semantic and acoustic tokens is that it's computationally expensive. And so the researchers were like, you know what, F the semantic tokens, we'll just use the acoustic tokens instead. And that led to much more efficiency. Higher latent rates versus lower latent rates. I think to maybe simplify this is like in the past they've taught the model to actually learn all the details. In the new method, it's more like instead of the model learning all the details of a book, let's just do summaries of the book, so it captured only like the high level details of like song structures, and that became like much more efficient. Questions so far in terms of like the methods of how this was trained and the approaches?
With the no semantic tokens, that means that it is just acoustic tokens. Is that
That's
correct?
correct. That's correct.
Thank you.
Yeah.
Thank you.
For like, what's the difference between semantic and acoustic tokens?
Yes. So semantic tokens are representations of like the themes of music, like the meaning, or how do I say this? Yeah, the themes. I don't know exactly like semantic tokens, like their proper definition, but the way that I tell myself is like it's the themes of the music itself. Um, while acoustic tokens actually represent the sound, that is going to be generated. You know, does that make sense to you, Avdesh? Okay, you're nodding. Okay.
Yeah. Yes.
Okay, cool. Let's move on. Oh, Vivek, yes.
No, that's good. That's good.
Okay,
I'm
okay,
just
cool.
stuff.
Copy that. Okay. So in terms of model architecture, this is my best effort to actually in a diagram draw how the whole model architecture looks like. Um, and one thing that I would also like to share is that when we look at AI models, and I used to think that they're just one model, but in reality, they are actually a mixture of models, right? So this right here, the clap, is a little AI. This one is another little AI. This one is another little AI. So altogether, it's like a it's like a transformer. It's like one robot, and then becomes like a bigger robot. So I think that's most of the approach with a lot of like AI building. It's like one neural network does this, another neural network does this, and they all just sort of like duct tape together to actually perform a certain use case. So recall when we put the prompt, right, on when you peel the layers, when you look under the hood, it sends our prompt to a clap encoder. And this is a neural network trained on text and audio pairs, right? So it understands the relationship between text descriptions and the audio itself, how it sounds. That spits out representations of it, which are here, audio embeddings. And then the audio embeddings are passed on to a diffusion transformer. And if you are familiar with Stable Diffusion, Midjourney, DALL-E, those image generation models, those models are called diffusion models. And if you're familiar, I mean, most of us here probably use ChatGPT. That uses a transformer model. So one thing that's novel here is that they also combined a diffusion and transformer into one. Boom. And then from there, once it runs through the diffusion transformer, it spits out representations of the data, which is then passed on to the autoencoder, which now generates the wave file or the MP3. And we can touch on briefly on these components and what they do. So let's start with the autoencoder here, which is the last part of the stack. What does it do? I think of it as sort of like, when we use zip and unzip, what it does, it down samples. When training, it down samples the input, which is the audio itself, into like lower resolution. Um, and that's how it learns. Sort of like one layer, high resolution, second layer, lower. So that's what the encoder does, and the decoder is essentially the unzipping of it. Now, when in production, when you're actually using this live, this encoder is actually frozen. This is not used anymore. And then, at stable audio, which we just did, this one is live decoder. What it does is like from the information coming from the previous neural networks, it sort of like generates and makes it into like a wave file. Now let's go to the diffusion transformer, which is again, quite interesting to me when I saw it. I hang out with a lot of like guys who work with large language models, and so I'm quite familiar with transformers and what they can do, and I think we've seen like the capability of the transformer model, how it could really create coherent text and understanding and reasoning. And diffusion model, again, very much used in production for a lot of like image models, and so the combination of both was really like interesting for me to actually see, and it's quite novel. And I think this has been sort of like a pattern with a lot of like excuse me, AI model building, where people actually see, oh, this model could actually do this. Oh, this model can also do this. Oh, why don't we combine them together? And so, this is the diffusion transformer. And the diffusion transformer actually has a lot of like good features when you actually combine them, right? Um, the model, it allows the model to generate music based on specific inputs of text. It understands like temporal dynamics, like it knows where, like as it's generating a song, it knows the sequence of like the song. Like it's like earlier, right, in our generations, like it knows like, oh, let's start with an intro. Oh, right now after 8 bars, let's start with a drop. And I think that's all thanks to the diffusion transformer, using, with transformers, it has its own like attention layer. Like it knows how to actually pay attention to certain parts of the data. um, and then also another feature that came off of this is also like it allows the model to generate different lengths. If we tell it to generate 30 seconds, it will generate 30 seconds. If we ask it 5 minutes, it will generate 5 minutes. um, so, yeah, I'll pause here if there's any questions or clarifications so far. Oh, Sid, quick question. What is this screen cap that you've shared? Music Gen?
Yeah, Music Gen. I think it's
Nice.
an open source project by Meta.
Mm-hmm.
And yeah, I saw this notebook on Hugging Face. So anyone wants to try, I have the notebook loaded if you want to try out any prompts.
Wonderful. Yeah. Music Gen. And it's interesting, Sid, because you mentioned Music Gen. Later on the evaluations, they actually compared this model to Music Gen. But like Sid said, Music Gen is a wonderful open source model. If you're interested in actually playing around with these types of models, I would also recommend Music Gen. And you could also easily train it as well on specific data sets that you have.
Yeah, this is
Cool.
like I had not heard of the combination of the diffusion transformer model, so excited to hear about it. And then Holly in the chat has shared a beautiful image on like a bit more detail on acoustic tokens versus semantic tokens in like a
Ooh.
like in a different form. So I'm adding them to the Figma board while we're going.
Amazing, amazing. Thank you, Holly. This is really very useful and very informational for me too. Acoustic versus semantic tokens. Wonderful. Um, cool. I think now for the last component of the model, and this is the first neural network that gets hit by our prompt, right? And you know, when we use Midjourney or Stable Diffusion or DALI, right? All of those models actually use a clip encoder. And a clip model, a small neural network, is trained typically on text and image pairs, right? So given a prompt, it understands, okay, this is what the user means. Um, so the clap is the audio version of that model. So clip and clap. Clip for image, clap for audio. And the cool thing about this little neural network is that it learns how to understand complex text inputs, and as well as like abstract concepts. Like for example, earlier in our prompt, right? Like, what does lo-fi R&B even mean, right? If you are a model, what does lo-fi R&B mean? There's a lot of like cultural aspects there too, right? Like one has to understand what is a lo-fi sound, and there's so many definitions, tape saturation, low resolution recordings, and then in modern terms, when you say lo-fi, you think about lo-fi hip hop, right? And so it's almost a combination of all these like semantics, but the model understood, lo-fi R&B, okay, this is what you mean. So that's thanks to the clap encoder. Now, how was it trained, right? I think the TLDR is that it took a long time. Um, so in when reading research papers and technical reports on model training, they use GPU hours, and I don't know what that means. But I found out that it's the number of GPUs that they have access to times the number of hours, and so you can just now infer that this took a long time, right? Um, and also when you compare to say a large language model, right, like Claude, for example, like they're saying, oh, it's like a trillion billion parameter model, right? They're talking about the amount of information that it has learned, right? um, and a trillion compared to 1.3 billion parameters, you would say, oh, this is tiny, but in the audio world, this is actually a lot. It's huge. So, autoencoder and the cloud training took about roughly 19,000 GPU hours. And with the diffusion transformer training, it's like roughly 85 GPU hours. But here's the interesting bit, and if I could add, when we train large language models like ChatGPT, it goes in like different phases, right? Like phase one would be pre-training. It's akin to like going to high school, where you actually learn all the general stuff, everything, your algebra, your history, like, all of that stuff. And then, the second phase is to actually fine tune it, and this is where you sort of specialize onto something. Think of it as like going to college. You have like a special degree with special subjects. And so the same process also is done on an audio model, where first they actually train it on like songs that are about like 3 minutes and 10 seconds roughly. And then because their aim was like, we want the model to actually understand and also like can generate longer songs. So we fine tune it on like 4 minutes and 45 seconds songs. And yeah, that's pretty much how they train the model. It's quite straightforward. Um, Here are some hyperparameters and all that stuff. Um, Yeah, question so far in terms of like training.
I have a couple, but I know we have 20 minutes left, Mark, so I'm wondering how many more slides. Maybe you're giving so much good
Yes.
information. I almost want you to just keep going.
Yeah, I got like a few more. So maybe about like two or three more.
The quick question then on training is like when you mentioned the pre-training versus fine-tuning, and let's say as an example, the 19,000 GPU hours uh for the clap training, I believe, or the
Correct.
autoencoder clap training. Like how much roughly on the 3-minute songs versus when you started to get to fine-tuning? Like if you break down that 19K, do you have a rough guess? How much is on pre-training versus fine-tuning?
That is a good question. That is a good question.
Go, something
There
we can check
is,
on later too. Yeah.
yeah, I have not found information on the research paper how they actually like split the training data, because when they talk about the data set, they talk about it like collectively.
Yeah.
But I'm pretty sure they probably hand selected, okay, 3 minutes, all the 3 minute bucket goes here, the 4 minute and over bucket goes here, sort of thing.
Yeah.
But I don't know the split percentage. Um, but I think based on my experience with fine tuning models, you don't need a lot for fine tuning compared
Actually,
to
sorry,
training.
I'm silly actually, because right on the diffusion training, it does say it right here, right? It says 70K GPU hours for the 3-minute songs, and then 15K GPU hours for the 4 minute 45-second songs. So I
Correct.
guess okay, sorry, I just missed those bullet
Oh,
points,
no
but
worries. Yeah, no worries. You
yeah,
good. You good.
thank you.
Um, let's talk about data set. And I think this is something that's very much like a like a hot topic, right? I don't know if you guys heard that Suno, which is a company building music AI models as well, just recently raised a lot of money. Um, um, and it's a wonderful tool, you know. But the thing that keeps on popping up is like the model is so good. Where did the data set come from, though? You know, because really, the lifeblood of AI is really data. No high quality data, no AI model. To be honest, so really, if there's a leverage point here, it's the data. Um, Thankfully, stable audio and the folks at Stability AI really care about making their data sources transparent. So on the research paper, they said that the data set was licensed from a music library called Audio Sparks. And Audio Sparks, as far as I've researched, is a music library that provides music for film, videos, Hollywood, stuff like that. Um, so remember that their aim was to actually build a model that could generate longer tracks, and so they found that the average song length for most of the music in the world is around 4 minutes 45 seconds. That's the mean. That's the average. So they were like, okay, let's have that as our target, you know, and so they chose songs that are around that length. Now, the audio files are about 800,000 files. 66% of them are music. 25 are sound effects, you know, like keys jangling, sirens, explosions, stuff like that. And then 9% of it are instrument stems, which are individually recorded instruments. And then, so that's the audio side. The text side of it is the natural language descriptions of the audio itself, right? With other musical metadata like beats per minute, genre, mood, and instruments. And so this is really very helpful, right? Like the text and audio pair as a data set allows the model to learn the relationships between both. And this data set with the audio and the text collectively uh, um, becomes the training data for all three components, from the clap to the autoencoder to the diffusion transformer. How did they know that it was good, right? And you know, the same as it is for software development, you know, we consider qualitative metrics and quantitative metrics. So on the quantitative side of things, yeah, they used FAD and KL divergence, which is essentially a measure of like how similar and how different the model generation is from real music. So typically with these scores, lower is better. Clap score is like how well the generation, the output aligns with the text prompts. And you know, as Sid like brought up earlier, Music Gen, their baseline, they compared it to Music Gen. And since this model is only trained on instrumental music, they only focus on instrumental music so that it's a fair comparison. Here is the scores. As you can see, just really quickly, when they ask the model, both models, Music Gen and Stable Audio, to generate a 2-minute track, it has good FD scores, lower is better here, good clap scores. And here's the interesting thing. Inference time, which is how fast the model generates, Music Gen took about 6 minutes, Stable Audio took about 13 seconds, right? Very fast. Now, when they asked the model to generate a longer track, 4 minutes, 45 seconds, pretty good KL scores and FD scores, pretty good clap scores. And check this out. Music Gen took twice as long, times 2, while Stable Audio remained at 13 seconds. So regardless if it's 2 minutes or 4 minutes, it's the same, you know. So it's quite good in terms of like inference. Um, let's talk about qualitative. You know, of course you have to have humans in the loop. It's humans who will be listening to music and who'll be using this model. So they used a tool called Web Mushra, where they invited different music producers, enjoyers, and researchers, and asked them to rate the output of the model, right, based on certain criteria like audio quality, text alignment, musical structure, musicality. You know, meaning the sensitivity or the pleasantness of the music itself, and stereo correctness. And they found that the model has actually gained a lot of the good scores in general. Um, but there's some variability in musical structure and musicality, right? And that led the researchers to believe that music appreciation is subjective. You know, what sounds like what sounds good to me, Vivek might actually found like, oh, this sounds like crap, dude. You know, and so it's kind of like it's subjective, you know, and so they also like wrote about that too on their research work. Um, cool. I mean, that's it for me. Just a quick recap. Stable audio or Stability AI has built stable audio, which can generate long form music 4 minutes over. It's very computationally efficient. It can do text to audio or audio to audio, and they have combined three little neural networks to actually build stable audio, which is the autoencoder, diffusion transformer, and clap. They've also introduced efficient training methods um, to their work, and it had a lot of good results, both on the quantitative side, it's better than music gen, and qualitative side too. Most humans like the music. So yeah, that's it for me. Thank you. Yeah, I want to hear everyone's observations, comments, questions. Yeah, I'm curious to
Amazing.
hear.
I'm gonna just say thank you to Mark, and yeah, please, anyone who has questions, thank you for sharing the whole time, Mark. I'm gonna have the Figma board up now, which I'll just be kind of writing into. It has all the slides and maybe some early notes, but there's some questions in the top right that I have, but I would love to hear from anyone else first if they have anything for Mark. Thank you, thank you, thank you.
My pleasure, guys. Thank you for listening.
Okay,
Maybe,
so yeah.
go ahead.
I'm happy to start with one. Just Mark, given we have 10 minutes left, and there's one thing that hasn't been discussed, but I know of your background, and of course the time at Song Camp, the participatory nature of music making, and that's why I'm so happy to have this presentation, because I know the depth to which you're going through this generative artificial music creation, but also the depth to which you've spent time with like making participatory environments for music making. So maybe like if we zoom out away from this a bit, but you tell us how you've been thinking about those two worlds, that could be interesting. We also can obviously go back into some of the specific parts of the presentation if it's helpful, but that was one question that came up for me.
Yeah, I mean, let's tackle that, right? It's I think my background in crypto and DAOs and open source really shaped me in terms of like how I think about these systems, right? How can this be participatory? How can we actually have democratized access and understanding and education, of all these like complex systems that would someday we would all use, right? One thing that comes to mind in terms of like participation and collectivity, and I've written an essay about this, how to build a decentralized AI. Um, and I think this was mainly from the point of view excuse me, of an artist, who is part of different collectives, different scenes, what would it look like if we as artists, like say for example, all of us in the group here are artists, and us as a collective have a defining certain shared aesthetic or approach or a method, say for example, we all make electronic music here, and the sound that we make has a very distinct feature to it. Let's just say that all of us here make bubblegum trance music, and we all share that sound. Maybe a different approach, with a different point of view for each individual member, but there is one defining sort of like feature that, say, the kernel label has, right? Now, how do we leverage that, and how can we use AI? Again, going back, data set is very important, and within that data set, if we actually pull our data set collectively, there's a sense of like the spirit of the kernel label embedded in there. Now, we could gather all of our data and fine tune a model that is open source and publicly available on our data, which we own, so once we fine tune a model, the fine tuned version we can now leverage or monetize collectively. And there's all sorts of different ways to sort of like build this collective, right? We could explore being a DAO, or we can explore being a cooperative. I think the term data cooperative comes to mind for me, which I feel like very fits the DAO model as well, although they can be on separate tracks as well. So I guess that's sort of like I guess my high level sort of like sketch of what it can look like. I would invite you guys, if you have time, to actually read the essay that I've written about it. It's quite long, but bookmark it if you're interested in the topic.
Yeah, I'll put it.
Just go to redito.substack.com. There you go. Thank you. Thank you.
Sure. Sid had a question. Sid, if you want to ask.
Oh, yes. Sid, have you tried training models on your own music? Yes, I have. I've used a model called Rave, Rave. It's on GitHub. And it allows you to build a model trained on any sound data set. And so I've tried creating a model based on my singing voice. I wouldn't call it good, but I would say I've had experimental results, which is fine, which is actually what I'm going for.
Cool. Cool. 5 minutes left. I curious if anyone else has anything. I mean, got this screenshot in here from Holly's note on acoustic
Oh, wonderful. That's really
versus
cool.
romantic.
If I could maybe put some thoughts, and would love to hear other folks as well. And this is probably expanded more towards like human and AI interaction. There is like amongst musicians and artists, and a lot of creative folks, really, there is this notion of AI automating away, our jobs, and replacing us. I I don't think that's the full picture of things, and I think we should also consider how AI could also expand our creativity, and lead us to find um, outliers in the creative search space. Like for example, earlier Vivek, right? Like oh, like oh, this is outside of the distribution. It can be a tool for us to actually find things that are outside of distribution. If a model is trained on, say, human knowledge and art, and obviously that is trained on like everything that we already know. But sometimes creativity is combining what has been done before with things that have been done before, combining it into like a novel shape that becomes like something new. So that's something to consider also. Although I also acknowledge the short-term risks of replacement as well. So would love to hear if folks have any statements around that or responses or comments.
I definitely, I'm compelled, and I'm compelled by like this approach that you've been taking, and honestly, you, right? Because the way that even you shared, and maybe even my own participation in today has helped me because you learn more about the models, right? And it's like the question is like, are you giving up your capacity to learn and create alongside, or are you not? And
Mhm.
if you are not, and if we are not, then it can be fun. Like today was
Mhm.
fun to like just
Mm.
understand the model a bit better, participate in the session with you, make a demo. And I think the same holds for the process of music making, even to some extent, the process of music consumption and the power that lies in our hands most clearly is our capacity to stay participants in the process. Yeah.
A thousand
That's
percent.
so
Yeah.
I resonate with it, while also appreciative that people have the risks in mind. Absolutely.
Hmm. Yeah. 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 I think something to add there too, as technologists, we there are times when we think that technology is detached from us. I think, and maybe people might disagree with me. I think it is a part of us. We've always been cyborgs. The first human who used a tool is a cyborg. They've extended their capability. And so with using now in 2024, where we actually have much more advanced intelligent tools, it's an extension of us. It's an extension of our cyborgness. um, and I mean cyborg in a way where it's just like a human that has expanded capabilities. And so, yeah,
Absolutely. Absolutely. There's one more question in the chat. I unfortunately have to drop in a second, but the question
no
was
worries.
if you have time, Mark, on music NFTs as it relates to this AI plus human music.
Mm-hmm.
Have you had any ideas, thoughts, perspectives on that?
Yeah. Maybe not the NFT side as well, but using crypto as a sort of like because crypto is really good for infrastructure and for like provenance and for data annotation, perhaps so using ERC20 or something um, similar could help in tracking the data set and you know building proof of like, oh yeah, this is the data set and this is actually the ledger that actually supports that data set. um, but on the NFT side of things, as a consumer, on the consumer side, I'm not sure. I don't see it yet. Yeah.
Cool. Cool. Fair enough. Mark, I have to drop. Thank you, thank you, thank you so much. I know Sid's gonna help us close out.
Okay, peace, Vivek.
Yeah. Thank you so much, Mark. If there are any other questions, we'll definitely send you all those questions in the chat over Slack. And if you have any more ideas for any future sessions, do let us know as well.
Absolutely. Yes, thank you for having me, Sid. Thank you, Holly, Avdesh, Chris. Thank you for tuning in. I appreciate you all, and I'll see
Thank
you on the
you.
Slacks.
Thank you, Mark. See you. Bye bye.
Thank you.
Peace
Goodbye.
out. Bye, guys.